Okay, good day. So today we're going to solve another indeterminate beam using moment distribution method. So this is my sample problem number 1. So we have a continuous beam, both ends fixed at A and D, then roller supports at B and C, and it is loaded with a uniform load of 30 kN per meter on span AB and a concentrated load of 120 kN at midspan of BC. So our objective using MDM is to calculate for the final moments at supports A, B, C, and D. Okay, the first step is to solve for the stiffness, K. Okay, since the beam here has constant EI, same elasticity value and same moment of inertia, so for the stiffness, okay, so let's start for the stiffness. So we'll be considering relative stiffness, okay? And the relative stiffness is just I over L. Okay, so let's start with span AB. So the stiffness on span AB is equal to I, and the length is 4 meters. Okay, then how about for the stiffness on BC? So that's I over L, or also 4. And how about the stiffness on CD? That's I over L is 3 meters. Okay, so this is the relative stiffness. Now to make our stiffness constant, so let us assume value of I be the multiples of the denominators of 4, 4, and 3. So we could let I be, say, 12. Okay, so if I would be 12, so this would be 12 over 4. So this would be 3. 12 over 4. So this is 3. And again, this is 12 over 3. So this is 4. So these are now the stiffness or stiffnesses of the 3 spans. Again, for span AB, the stiffness is 3. So I write here. Then for BC, it's 3 also. Then for CD, it's 4. So these are the relative stiffness of the beam. The next step is to solve for the DF. DF is the distribution factor. Okay. Distribution factor is applicable for every joint. Okay. Let's say, so that would be the stiffness at a joint divided by the summation of the stiffness at that joint. No? So stiffness at that point of the member divided by the stiffness, the summation of the stiffness at a joint. Okay, so at a joint. Okay, so let's say what is the stiffness on AB? So here. So since point A is a fixed support, the distribution factor there is always 0. Okay, so this is 0. Okay, how about the DF here? So the DF here would be DF on BA. So that is the stiffness on this member, which is 3, divided by the stiffness or the stiffnesses, the summation of the stiffnesses of the members at this joint. So the members are 3 and 3. So 3 plus 3. So that is 3 over 6, or that is 1/2 or 0.5. Okay, so 0.5, 0.5. Next here is what's the DF on member or member BC here at this point. So that is the stiffness on this member, 3, divided by the summation of the stiffnesses, 3 plus 3. So that would be 3 over 6. That's also 0.5. Okay? So 0.5. Okay, how about the DF here? DF here on CB is equal to the stiffness on this member, so 3, divided by the summation of the stiffnesses at this joint, so 3 and 4. So that is 3 over 7. Okay, 3 over 7, 0.4285. So let's make it as fraction form, 3 over 7 na lang. here, dF on CD is 4, the stiffness here, divided by the summation of 4 plus 3. So that is 4 over 7, fraction. And finally, what's the dF on DC? Again, point D is a fixed support, therefore the distribution factor there would be 0. So because this is fixed support. Kapag ka hinge or roller naman yung dulo ng beam, the distribution factor there would be equal to 1. Okay? So these are now the distribution factors. The next is to identify the fixed end moment. Okay, so what are the fixed end moment? Okay, so fixed end moment. Okay, so for member AB, so that is a uniform load. Okay, so it's a uniform load. What's the fixed end moment for a uniform load? Say W and L. But the fixed end moment to the left is counterclockwise. Here is it's clockwise. So the FEM on AB is equal to WL square over 12. And this is counterclockwise, so that's positive. Now, yung sign convention natin sa MDM is the same with the sign convention that we have on a slope deflection method, in such a way that we could assume initially that the member end moments would be positive. That means counterclockwise. Okay? So from the moment na mag-negative yung sagot natin sa final, so that means that the end moments are opposite in direction. Okay? So this one would be W is 30. So we have 30. The length is 4 meters square over 12. Okay, so 30 times 4 square over 12, so that's 40. So that's positive 40. Okay, how about for this right side? So that would be the FEM on BA. And that would be negative WL square over 12. And that would be negative 40. Okay, so again, the FEM here is positive 40. Here is negative 40. That is due to the uniform load. What about for the span of BC? What is the fixed end moment? So that is a concentrated load at the midspan. So for concentrated load at midspan, L over 2, L over 2, counterclockwise, this is clockwise, this is PL over 8, positive, and this one is PL over 8, negative. So therefore, the fixed end moment on member BC, which is sa left, that would be plus, what's P? P is 120 and the length is 4 meters. So 120 times 4 over 8. 120 times 4 over 8. So that's positive 60. While what about on the right side? So that is the FEM on CB. That would be negative 60. Okay, so positive 60 here. Positive 60, and this is negative 60. Okay, then how about for CD? Since for span CD there is no load, therefore the fixed end moment there would just be 0. Okay, so again, the stiffness, we have the distribution factor, and we have the fixed end moment. Okay, the next step is to calculate for the unbalanced moment. Unbalanced moment. Okay? So, what would be the unbalanced moment? Okay, the unbalanced moment here at this joint is negative 40 plus 60. So, there is an unbalanced moment of positive 20. Okay? Whereas on this joint naman, it's negative 60 tsaka 0. So, the unbalanced moment here is negative 60. So, these are the unbalanced moments at joint. Okay. So, the next step is to balance the moment in a joint. Okay. So, we have to calculate now for the balance at joint or the balancing moment at joint. Okay. So, how do we do that? So, that would be, let's say, let's start with this one. So again, it's negative 40 plus 60. So the unbalanced moment is positive 20. So to solve for the balance at joint, we multiply the unbalanced moment 20 with the negative of the DF. Okay, so again, so how do you solve for the balance at joint? So that would be the unbalanced moment times the negative of the DF. Okay, so yan yung equation na gagamitin natin for the balance at the joint. Again, so going back here, so the unbalanced moment here is negative 40 plus 60, so we have positive 20. Positive 20 times the negative of 0.5. Negative of 0.5, so we got negative 10. So here is negative 10. How about here? So the unbalanced moment again is positive 20. Positive 20 times the negative of 0.5. Okay, so that's negative 10 also. Okay, so to check if your balance at joint moments are correct, dapat yung summation ng moment natin at a joint after having this balance at joint should be 0. Diba? Negative 40, negative 10, negative 10, so that's negative 60. Plus 60, 0. So, dapat yung summation ng moment mo at a joint should be equal to 0. Okay, so ganun ang pag-solve ng balance at joint. Okay, how about for this joint naman? Oh, how much is the unbalanced moment? Diba, negative 60 at saka 0. So, the unbalanced moment here is negative 60. So, that's negative 60. That unbalanced moment of negative 60, i-multiply mo sa negative of the DF. So, times the negative of 3 over 7. So, that is 25 point, let's have 4 decimal places, 7143. 7143. Okay? So, how about on this side? The unbalanced moment is negative 60 times the negative of 4 over 7. That is 34.2857. Okay, 28.57. Again, pagka in-add up ko lahat ng summation ng moment na to, tingnan natin ha, negative 6, tingnan nyo, negative 60 plus 0 plus 25.7143 tsaka plus 34.2857, dapat ang summation natin is 0. So, 0 naman. Okay? So, how about dito sa fixed support? Ganun din. So, the summation of unbalanced moment here is positive 40 at this joint times the DF of 0. So, that would be 0 also. Likewise, dito naman sa right end, 0 ang fixed end moment times the negative of the DF. So, 0 pa rin siya. Okay? So, those are the balance at joint. Now, ano yung COM? COM is the carryover moment. COM is the carryover moment. Okay? So, mag-ano tayo dyan? So, mag-criss-cross tayo. So, we're going to carry over the moment to the other side of the member. Okay? So, and the carryover moment is just equal to the balance moment, balance at joint, divided by 2. So, that is also 1/2. So, kukuhain mo lang yung 1/2. Okay, let's see. So itong negative 10, i-criss-cross natin sa kabilang side, yung 0, i-criss-cross din natin doon. So, 0 divided by 2 is 0. Negative 10 divided by 2 is negative 5. So, yan. So, x mo lang natin yan. So, dito rin, i-x lang natin siya. Yung negative 10, kalahati niya, i-transfer natin dito. So, that's negative 5. Yung 25.7143 divided by 2, 25.7143 divided by 2, that's 12. So, dito yung 12. 12.8572. Then, dito, 0. Kalahati ng 0 ay 0. Ito, kalahati nito. Lipat natin doon. So, 34.2857 divided by 2, we have 17.1429. Ayan. So, yan na ngayon yung first na carryover moment natin. Okay? So, what's next? So, balance at joint uli. Ibabalanse uli natin yung mga moment natin sa joint. So, paano gagawin? Paano pagkuha ng balance moment? Okay? So, isolve natin yung unbalanced moment uli sa joint. Okay? So, for this case, the unbalanced moment here dito is 0 tsaka 12. Diba? So, then, dito muna tayo mag-start. Negative 5. So, negative 5 times the negative of df. So, 0 pa rin siya. Okay. So, dito naman sa joint na to. 0 tsaka 12. So, syempre, 12.8572 yan. Okay? So, yan yung unbalanced moment. I-multiply uli natin siya sa negative ng df. Kaya naka-highlight ko yung df dito kung mapapansin nyo. Kasi yan yung multiplier natin parati sa pagkuha ng balance at joint. Yung unbalanced moment, lagi natin siya i-multiply sa negative of the df. Hinighlight ko yung df dito para mas madali natin makita. No? So, parati kasi natin gagamitin yung df. Again, 12.8572 times, for the balance at joint here, negative of 0.5 times negative of 0.5. So, that is negative 6, 4286. 4286. So, dito rin, negative 0.5 din. So, parehas lang. Negative 0.6, 4286. How about dito? So, negative 5 tsaka 0. So, the unbalanced moment is negative 5. Diba? So, negative 5 times the negative of 3 over 7 times the negative of 3 over 7. So, that is, this is 2.1429. Okay? Tapos, dito naman sa 4 over 7, negative 5 times the negative of 4 over 7. So, that's 2.8571. Again, to check kung tama itong mga ginagawa natin, you get the summation of all these moments at this joint. Dapat 0 ang sagot. Then, for this one, 17 times 0, so 0 pa rin siya. Okay? So, yan yung balance moment. Next, ulit. Carry over moment ulit tayo. Okay? Paulit-ulit lang. No? So, balance at joint, tapos carry over moment, balance at joint, carry over moment. So, kailan tayo mag-i-stop? Mag-i-stop tayo kapag kayong COM natin. So, stop the moment distribution method if the COM is approximately 0. Okay? Approximately 0 or negligible. So, sa atin, siguro gagawin natin, let us stop if COM is 0.00 something. Yan, 0.00 something. Stop na tayo. So, doon tayo mag-e-end sa COM. Okay, so, balik ulit tayo rito. Okay, so, what about the carryover factor again? Carryover moment. So, again, criss-cross na naman. So, x. So, yung 0, kalahati niyan, 0 pa rin. Itong 642, kalahati niya, negative 6.4286 divided by 2, kalahati is negative 3. 2143. Okay? So, same thing here. Okay? So, yung negative 6.4286, this one, divided by 2, So that's negative 3, 2143. Okay, so ito naman yung 2.14, 29 divided by 2. So we got 1.0715. Then for this side, 0. Then the 2.85, 71 divided by 2, it's 1.4286. Okay, so these are the COM again. So as you can see, medyo malalaki pa yung COM natin, no? 1.073. So mag-stop tayo pagka 0 na yung mga yan, or negligible, mga 0.00 something na yan. So moving on ulit, what would be the balance at the joint again? So ganoon na naman. So the unbalanced moment at this joint is negative 3 times the negative of df, 0. So 0 pa rin to. At this joint, the unbalanced moment is 0 tsaka 107. So 1.0715, that's the unbalanced moment at this joint, times the negative of the df. The negative of 0.5 times negative of 0.5. So I got negative 0.5358. 5358. So same here, no? Negative of 0.5. So pares din. 5358. How about on this joint? The unbalanced moment here is negative 3.2. 3.2143. Okay? Times the negative of 3 over 7. So that is 1.3776. 3776. Okay? How about on this side? Negative 3.2143 unbalanced moment times the negative of df, the negative of 4 over 7. So that is 1.83. 67. Okay, so here, unbalanced moment is 142 times the negative of df. df is 0, so 0 pa rin yan. Okay, so next, let's solve for the COM, or the carryover moment. So how do we do that? So cross lang, no? Then get the 1/2. So 0, 1/2, 0. This negative 53, so negative 0.5358 divided by 2. So we got negative 2679. 2679. So here, okay, so negative 0.5358. So that's the same with this. 0.2679. How about this 1.37? 0.76, 137.76 divided by 2. So we got 0.6888. Okay? Then here, 0. Here, 1.8367 divided by 2. Laging divided by 2 kasi carryover moment natin is 1/2 or 0.5 or divided by 2. That is applicable whenever we have prismatic section. So here is 0.91, 84. Okay, so as you can see, lumiliit na yung mga COM natin, no? Point something na lahat sila. Okay, so isa pa. O, paano pagko ng balance moment ulit? Balance at joint. So solve for the unbalanced moment. So negative 26 times the negative of df. So 0 pa rin to. Here, the unbalanced moment is 0 plus 0.68. 0.6888 times the negative of df times negative of 0.5. So that is negative 3444. Okay, 3444. So dito, ganun din. Negative 0.3444. On this side, the unbalanced moment is negative 0.26 tsaka 0. Negative 0.2679 times the negative of df times the negative of 3 over 7. So we got 0.11 here. 48. Dito naman, negative 4 over 7 is positive 1531. 1531. Here is 0.91 times the negative of 0, 0 pa rin. Okay. Again, for the balance, no? So that's balance. Next is COM. So, paano pag COM ulit? Ganun ulit, no? So, cross lang. So, 0. This one, negative 0.3444. Okay, divided by 2. So, that's negative 0.1722. Here. 0.1722. This one. 0.1148 divided by 2. So, we got 0.0574. Here, 0. 0.1531 divided by 2. This is 0.0766. So, ano ng value ng COM natin? 0.05 tsaka 0.17. Isa pa. Okay, so balance ulit tayo. Balance at a joint. Okay, so balance at a joint. So, 0 ulit dito. Negative 0.17 times the negative of 0. So, 0. Dito, ang balance moment natin dito is 0 tsaka 0.05. So, 0.05. 0.05, 74. Ito yun. Times the negative of df. Times the negative of df. So, we got 0.287. Same dito rin. 0.0287. Dito naman, unbalanced moment is negative 0.1722. Ito. Times the negative of df. Times negative 3 over 7. So, we got 0.0738. Dito naman, times negative of 4 over 7. So, we got 0.0984. Okay? So, dito naman, 0.07 times the negative of 0. So, 0 pa rin. Okay, so, ano pa? COM. Diretso natin COM. So, ganun ulit. Kalahati. Crossover. So, 0. This is negative 0.0287. 0287 divided by 2. So, that's negative 0.0144. Okay. This one, ganun din. 0.0144. Ito 0.07, 0.0738 divided by 2. 0.0369. Okay, dito x uli, x 0.0984 divided by 2. 0.0492. So, 0.01 pa, 0.03 pa, no? So, isa pa uli. Mag-i-stop tayo kapag yung COM natin is 0.00 something na. Okay, so again, 0 dito. Ito, 0.0369. Unbalanced moment times the negative of df times negative of 0.5. So, we got 0.185. Okay, so same here, 0.00185. Okay, how about here? So, minus negative 0.144 times the negative of 3 over 7. So, we got 0.0062. 62. Okay? Tapos, yung isa naman is 0.0082. Okay? Then this one is 0. Okay, next, COM. COM naman. So, Okay, so this would be 0. Ito, negative 0.0185 divided by 2. Negative 0.0093. Ayun, so 0.0093 na. Okay, so dito naman, ito 0.0185 divided by 2, parehas lang ito. Negative 0.0093. Okay, how about this one? 0.0062 divided by 2. So that's 0.0031. Okay, then on this side, 0. 0.0082 divided by 2. So that's 0.0041. So as you can see, yung mga unbalanced moment natin sa joint is 0.00 something na lang. So from there, we could stop there. So yun na yung magiging last COM natin. Okay? So ibig sabihin, yung cycle natin depende. So mas maraming cycle, mas magiging accurate yung final answer natin. Okay? And I believe with a COM of 0.00 something, that would be an accurate enough. Okay? So pagka yan na yung dulo, hindi yan na yung dulo. So finally, we could solve for the final moment. Okay, yung final moment, okay, so yun yung say FM. Yan yung mga final moments dun sa ano. So the FEM would just be, okay, so yung final moment would be the summation of all the moments from FEM hanggang sa last na COM. Yan, so from here hanggang dito. So lahat yan, isa-summation natin, yun yung final moment. Okay, so let's say for at point A. So ang isa-summation natin simula sa FEM, no? So 40. So we have 40 minus 5 minus 3.2143 minus 0.26 79, then minus 0.1722, then minus 0.0144, then minus 0.0093. So the final moment is 31.3219. Okay, so that's the final moment at joint A. How about at joint B? Ganun din, isa-summation lang natin yung from the fixed end moment, diretso hanggang doon sa huling COM. So that would be negative 40 minus 10 minus 6.4286 minus minus 0.5358 minus 0.3444 minus 0.0287, then minus 0.0185. So the final moment is negative 57.356. Okay, so how about for BC, moment on BC? Again, summation of FEM, so positive 60 minus 10 plus 12.8572 minus 6.4286 plus 1.0715 minus 0.5358, no, this one, plus 0.6888 minus 0.3444 plus 0.0574 minus 0.0287 plus 0.0369 minus 0.0185 plus 0.0031. So that's positive 57 3589. So, one way or one method to check whether final answer is correct, dapat yung moment, magnitude at a joint should be the same and oppositely directed. So, negative 57, 35, positive 57, 35. So, most likely, this is correct. Dapat parehas ng magnitude, opposite yung direction. Okay? So, how about for dito sa joint C naman? So, from FEM, negative 60. Negative 60 plus 25, 7143 minus 5 plus 2.14 minus 3.21, 43, 1.37, 76, 0.26, 79, 0.11, 48, 0.17, 22, plus 0.0738 minus 0.0144 plus 0.0062, then negative 0.0093. Okay, so the final moment is negative 39.2485. Okay, then on this side naman 0, 34.28, 57 plus 2.85, 71 plus 1.83, 67 plus 0.15, 31 plus 0.09, 84 plus 0.0082. So that's 39.2392. So almost the same na, no? So negative 39.2, 39.2. Yung konting discrepancy dyan, that is caused by the rounding of numbers. No? Kasi diba what we did is we rounded numbers up to 4 decimal places. Okay. So then last, for the last one, so 0, so we have 17.14, 29 plus 1.4286 plus 0.9184 plus 0.0766 plus 0.0492 plus 0.0041. So the answer is 19.61. Okay. So these are now the end moments, the final moments. So positive 31 means the direction is counterclockwise. Negative 57, that means mali yung direction natin. It should be clockwise. No? So consistent pa rin yung sign convention natin, with the final answers. Okay? So if I ask you what is the final answers. Okay, so the moment at A is equal to that's 31.3219 so that's kilonewton meter, and that is counterclockwise. Okay, so counterclockwise. So what's the true sign of the moment? So that would be counterclockwise. So it makes the beam sad face. So the true sign would be negative 31.3219 kilonewton meter. Okay, how about the moment at B? The moment at B is, if you will look at on this side, the moment at B is negative 57. So I could write it as, say, 51.356 kilonewton meter. And that is negative to, so that means pag ganon, no? So pag ganon. So what's the true meaning? So it makes the beam sad face ulit, diba? Sad face. Kaya this is negative 51.356 kilonewton meter. How about the moment at C? The moment at C is here. So we have 39, 24, 85. Okay. So this is, it should be clockwise on that direction. So that makes the beam sad face ulit. Kaya negative 39, 24, 85. And lastly, the moment at D is 19.6198. Again, that is counterclockwise, positive. Tama ba? So, counterclockwise. So, it makes the beam happy. So, that would be positive 19.61 kilonewton meter. So, these are now the moments at the supports. So, if you want to solve for the reactions, the vertical reactions at the support, you just apply statics. So, pag na-solve nyo na itong mga moments na to by applying statics, you can solve for the reactions. Okay, so this is my sample problem number 1 on MDM. So, I hope you have learned something about this. So, you could just ask questions if ever you have any. Thank you.